Again, today I'm doing things a little bit different. You see, I signed a contract not too long ago to do a project very close to my office, and I think that this is a great opportunity to show you what's going on behind the curtain in an architect's office, in my office to be precise. This way you get to better understand what happens from start to finish of a project, if we eventually get there at some time down the line, in 2 years' time probably. Anyway, today we're at the start point of that journey. So, site analysis. Site analysis is actually one of the many things we architects started doing in what we call the preliminary phase. This is where we start poring over all the documentation we receive, and very importantly, even before doing that, we get the contract signed, in most cases at least. But what is site analysis exactly and how we get about it? Well, that's what this video is all about. Site analysis is a matter of understanding the constraints I'm going to be working with. And these are very important, as you can probably imagine. But we tend to think of a complicated site as one that has many constraints, very many constraints actually. But that's far from being the case, to be honest. This is why many architects, myself included, think it's a lot easier to work in an urban setting where constraints are clear, at least in most cases, and not in the case I'm going to show, but nevertheless, than it is to actually work in the middle of a field where the possibilities are just endless. Site analysis is actually a three-step process, with the actual analyzing of the site being the last of that process. We first have to start with what I just mentioned a moment ago, poring over all the documentation we get. We do this because we want to understand better what it is we're working with. For instance, if the plot I'm working with has a servitude towards one of the neighbors or some other similar thing, I want to know that first thing. It's crucial information, and it shouldn't come at a later stage. Poring over all the documentation also means looking at the plans the client sends me. This is the plan I got from the surveyor. And this here is my client's plot. The north is to the top of the screen. My client's plot is actually made up of two plots. A larger one to the north, which we'll call plot 1 and leave the creativity or something else. And then we'll call the smaller one to the south, plot 2. This second plot already has a house in it, but it's in quite a bad shape, as you can see here in this photo. The idea for this project is to build a multi-residential building to the street and then the client's own house towards the back, with an independent access from the curb. Upon studying this plan, I already see quite a few things that call my attention. Now again, I want to do this beforehand, before setting foot on the site itself, because I want to know what it is I'm going to be looking for in the site. I mean, I know myself, otherwise I'd be just too distracted taking pictures and drawings and whatever, and I would probably miss out important information that I had to pay attention to. The first thing that calls my attention when I look at my surveyor's plan is that the southern limit seems a bit off. And what I mean by this is that there's two different limits. And I'm getting the sense that my neighbor to the south has actually eaten a chunk of my client's land. This is not necessarily a problem. I can probably work with this, and I will actually try to integrate this into my design because, as I just said, it's quite close to my office. I don't want trouble with the neighbors. And also, as I'll explain later, I need to have a good relationship with my neighbors for my project to go ahead. And another reason is I'm quite an empathic guy. I'd rather avoid giving trouble to a neighbor if I can avoid it. So let's try and integrate this. I'm already quite familiar with the site. I go by it basically on a weekly basis. And I know that the slope is important, but I had no idea there was at least a 6-meter difference between the entrance to one plot and the entrance to the other plot. I mean, this represents a 2-story climb. This is something to already take into account into the site analysis. other than the fact that this is a one-way street going up the climb, we should acknowledge that cars, or I should probably say drivers, tend to accelerate on the bottom of the hill, making more noise and throwing out more pollutants. So this is something to be considered on site, but to a point nowadays, because this project is probably going to be built between 2 years' time, and normally in about 5 years' time, most cars around here would be switching to electric, and they don't carry the same problems. But still, something to bear in mind whenever I do site analysis, because this normally will have an impact on the way people use the buildings. I mean, if it's very noisy, people are not going to open the windows to increase airflow and therefore reduce the temperature. This significant slope also means that if we're going to put any kind of underground parking, the access ramp is going to have to be in the lowest part of the plot. That would be where the current house actually sits. Now to the site. As I said, it's only a 5-minute walk to the site from my office, which is a hell of a luxury, and I had the possibility of going there several times. Once on site, there's something that immediately catches my attention. And to be honest, I was expecting this because, again, I know the place. And it's a major issue. You see these windows? Well, those shouldn't be there. That's a party wall. Party walls are normally meant to be blind. And as far as I know, the plot I'm working with has no servitude towards these windows, which means I could probably ask this neighbor to close off those windows, but I'm pretty sure that they wouldn't be too happy about it. And again, I want to keep things amicable, as much as possible at least. So once again, I try to integrate that into my design, always without hindering my client's prospect. So you see, this is already beginning to be tougher than normal. You may be thinking at this point that I'm being just far too generous with the neighbors. But the reality is that building in Belgium is complicated. I mean, there are guidelines for building, but they're not set in stone. And if all neighbors start to complain about my project, they could really create headaches for me and my client. So if I approach this by just trying to mess everybody up, nobody's going to be happy and nobody's going to get anything out of it, much less my client. I didn't get the measurement of these windows in my plans I received from the surveyor, so I'm going to take this opportunity to measure them myself. While on site, snapping a few pictures is always a smart idea. But this is only to a certain extent, once again. You see, when I'm snapping pictures, I'm thinking more of if I'm getting the frame right and how's the light. And normally I'm raising the camera when there's a subject I really want to take a picture of, take a note of. But sketching on site also carries a lot of power. Not because my sketches are brilliant or anything. As you probably saw before, that's clearly not the case. But drawing actually forces me to pay attention to the surroundings and the relationships between one thing with the other. You can do that with photos afterwards, but I can guarantee to you that it's not the same. When I sit and draw, it forces me to take my time and spend it on site doing these sketches, which are again only 5-minute sketches. But while I'm there, I'm listening to the cars, I'm paying attention to the surroundings, I'm seeing the amount of pedestrian traffic coming and going, and I'm getting a general sense of the site. Here's an example of what I was just saying. See, in this drawing, I drew the houses in front of my plot, and as I was drawing them, I realized that from the street, I couldn't see the pitched roof that these houses had. The cornice was coming out so far into the street that it was covering that roof. So I had no idea how the roof was actually made. This probably seems trivial, but again, it helps me get a sense of how you feel in this space. That's why I also took a moment to draw the school, which is very close by. And then another thing I like to do now in more recent years is fly my drone. I mean, we can always look at the satellite images, but these are limited. The drone allows us to have perspective, an aerial view, which is, for me at least, invaluable, because I can see the relationship with other important places in the nearby surroundings. And you can see how my site is located within the urban tissue. You can see that steep climb where those cars are going by, and the relationship my site has with the center of this town where the church and the council are located. Okay, now for the third part of that site analysis process, which is the analysis itself. So to recap, the first one was looking over the documentation, the second one was actually going to the site, and now we're at stage 3. Now when I'm sitting back in my office, again, what I like to do for a project of this scale at least is a 3D model of the site. And I like to build a model of that site. But as I just said, this usually comes down to the scale of the project. If the project is too small, it probably just doesn't justify doing a 3D model of it. It's just going to require a lot of extra time, which I would then have to either absorb or bill to the client. And in either case, one of the two parties are not going to be happy about it, unless special situations demand it. But whenever I can, I try to push for the model. Because as a designer, the 3D model gives me a lot of tools. Today I can print this 3D model, which allows me to better understand certain proportions and connections, more or less like the drone did. And not only that, the model is a great communication tool. For this particular project, I'm really going to have to leverage this model because my approach is to have an open dialogue with neighbors and the council. And they're not all architects, so I really cannot expect them to understand plans. But models are much more engaging. That's basically their interest. Here I printed the 3D model of my site, and I printed it in a particular way so that I can swap certain pieces with other ones so that I can test different design ideas. This also allows me to see sections of my model or seeing the plot itself without its surroundings, so I can take a better look at my project. Now that I have built the model, I can use it to better understand its relationship with the sun. Of course, I can throw in a sun path diagram and get a sense of how much sun I'm actually getting, but the only purpose I see this serving is just to dazzle you, and to be honest, I want to do more than that. So there's nothing wrong with the sun path diagram approach, but the reality is that the sun path diagram is only going to illustrate how much sun I am getting on a particular day and hour in one particular point, which is not as interesting as it is to know how much sun I'm getting throughout the year in my whole site. And for that, what I do is an incident solar radiation analysis. Now that I have the model, this is easy to do. And I ran the simulation for the warm period, which is made up of the 3 months from June to August, and also for the cool period, which is a 5-month-long period made up by the months from November all the way to March. If you would like to learn more about my climate analysis, be sure to take a look at the video, which I'll link in the description below. Now, as I said before, the legislation here in Belgium is a bit loose. I mean, there are guidelines, but these are not necessarily set in stone. According to these guidelines, my building will not be taller than 8.5 meters tall. And the slope of my roof has to mimic the slope of my neighbor. So now I can more or less get an idea of a base case scenario. That would be maximum height, respecting all the slopes. And we can simulate, again, community values, the warm period and the cool period, and see how these compare to the previous scenario, where there was nothing built or only the existing house, so the current scenario. This is much more valuable than seeing and understanding how much sun a certain point is receiving throughout the year, which is the information I would have gotten from a sun path diagram. because it allows me to understand how much my new building is going to be affecting that neighborhood, and also how much sun can I be exposed to with my building. So now I can put a number into how much sun I'm actually blocking from my neighbors with different scenarios and different possibilities. It opens up questions like, am I okay with blocking the solar radiation falling into the solar panels of my neighbor? If I am, up to what point? Can I expect the neighbor not to complain for me doing so? Of course not. But we have to open the discussion, so probably they would have to understand that I have the right to block a certain amount, but I would also have to understand that with my design, I cannot just not care. Ultimately, this is a tool that will help me understand up to what point I want to limit my own building's impact into this neighborhood. And these are all very important questions that have to be answered when I do my iterations in the following video.